Hi, in this video we're going to do a wee recap of the topic composite and inverse functions. So this topic is all about functions and domain and range and things like that. So here is like an illustration of a function of when one exists and when doesn't exist. So a couple of things to point out here. The domain is your input numbers. So if they ask you for a suitable domain, it means what kind of numbers can you put in. And the range is output, so that's what will come out. For a function to exist, every single number in the domain has to go to a different number in the range. Okay, now it's okay for like these two numbers to have the same output, but they have to at least have an output number. If you look at this one over to the right, the number 1 has an output, the number 3 has an output, but the number 2 doesn't. So a function doesn't exist there. So a function only exists if you have an answer when you put it in. So if you come out with an answer to the function. So a couple of points to remember is they will ask you for suitable domains, they will ask you when functions are undefined. It all comes down to the same things, you just have to watch your sway on the wording. So if you've ever got a fraction, the denominator cannot ever be 0. So quite often in maths you'll see things written as maybe that, and at the side it will say x cannot equal -4. And the reason that is because if you put in -4, the bottom line would give you 0, so you can't have that. In maths, you can't divide by 0. So that would be a suitable domain for that one. So I could put in any number but x equals -4. Similarly, if you had the square root of x plus 4, that bit under the square root cannot be negative. You put the bit there greater than or equal to 0 because it can be 0. You can square root 0. It's just 0. But put the bit underneath saying that it's got to be bigger than 0. So x is greater than -4. That would be your domain for that one. If they asked you for a suitable domain, that's what you'd write. If they ask you when is it undefined, you would say undefined when x equals -4, undefined when x is less than -4 in that case, okay, because that is when it would give you an unsuitable answer. So each of these questions want you to write down a suitable domain for these questions. So the first one, remember I've said the bit under the square root can't be negative. So you would put 4x take away 12 is greater than 0. And then you would just rearrange that like a normal equation and it would be x is greater than 3. So your domain would be all real numbers where x is greater than 3. Okay, and we write all real numbers as x belongs to the group of real numbers. Similarly, the square root of this one, so you would say, right, that's got to be greater than 0. So you would say x squared minus 5x is greater than 0. This one's got a wee common factor going on of x minus 5 is greater than 0. Now, x squared minus 5x is a smiley face quadratic that cuts at 0. And if you solve that, it's at 0 and 5. We want this greater than 0, so we want these bits here. So when that one, it would be x is less than 0 and x is greater than 5. Okay. And the bottom two are fractions, so the bottom line cannot equal 0. So you put x plus 2 equal to 0. X equals -2. So that means that x cannot equal the number -2. Okay. Similarly with this one, you put the quadratic equal to 0. I'm going to go straight into the two brackets here. But I noticed a wee mistake with the number, so that's why it's just changed to -4. So factorising this gives you x plus 7x minus 2. And if you put that equal to 0, you get x equals -7 and x equals 2. So x cannot be either of those two numbers because they would give you out as 0. So they're suitable domains, all right? Now that's all what you can put in, but they can swing it and they can say, when is a function undefined instead? And what that means is undefined, and it's the kind of opposite. So it's undefined, if I look at this bottom one, it's undefined when x equals -2. This one is undefined when x equals -7 or +2. The top two, the first one would be undefined when x is anything bigger than 3. And the second one would be undefined when x was any number between 0 and 5. So the way they ask it depends how you write the answer. Domains are things that you can't put in. Undefined are things that will give you undefined answers when you do put them in. Either way, let's look at these. So these are composite functions. Composite in maths means putting things together. Composite class means mixing classes. Composite shapes, putting two shapes together. So it's natural that this means mixing two functions together. So our functions here are f of x and g of x. So you start from the inside and work your way out. So if it wants f of g of x, we replace the inside with whatever g of x is. So this becomes x squared minus 6 in the middle. So I've replaced g of x with that. Then into the f of x equation, wherever you see x, you now replace it with a bracket. So this becomes, this becomes x squared minus 6 plus 4. I don't really need that bracket around that first bit, but that's what that becomes there. So it's x squared minus 6 plus 4, which if you tidy it up is just x squared plus 2. The second one starts from the inside out, so that will be g of x plus 4. So whenever you see x squared, you replace it with this bracket. So in this case, so whenever you see x, you're replacing it with the bracket. So we've got an x squared this time, so this will become your bracket squared. And then I'll take away 6. And then you'd multiply that out. That gives you x squared plus 8x plus 16. Take away 6. And that gives you x. It gives you this. I'm talking nonsense now. So there's your answers for those ones. And generally people are quite good at these. Then they put a different spin on it and they tell you what f of g of x is and you have to work out what a. In this case it tells us that f of g of x and g of f of x are equal. So we can then work out what a. So that's what we're going to have to do, is we're going to have to work out the two things. So f of g of x, just like we did in the last example, is f of 5x plus a. So I put that in here where I see the x. So I've got 3 bracket 5x plus a plus 1. I'm just going to expand that out and that gives me 15x plus 3a plus 1. If I do g of f of x, that means I am going to replace, so that's g of 3x plus 1. So where I see this x now, I'm going to put in 3x plus 1. So that's 5 bracket 3x plus 1 and there's a plus a. Expand that out, it's 15x plus 5 plus a. Now it tells us these two things are equal. So what I can do now is I can put them equal to each other. So I'm making a new equation. So I've got this equals this. So from there the x's will cancel out, so they disappear. If I bring my a's over to the left hand side, I've got 3a take away a, and then I've got a 5 take away 1. So I've got 2a equals 4, so a equals 2 for your final answer. Okay, now I'm going to talk about inverse functions. So inverse in maths means doing the opposite, right? The inverse of timesing by 2 is dividing by 2. Inverse of adding 4 is subtracting 4. So the inverse function is the reverse. And if it exists, then every single member of the domain must match exactly to one member in the range. I.e. you need to get back to where you started from. So if you look at my first example, every single line goes to one other number in the range. But if you look at the second one where it says no inverse, I've got two input numbers giving you the same output. And then I've got another 2 input numbers giving you the same output. So they, that's fine. But this wee one in here didn't have an input. So this one has no inverse. Okay. And also because there was 2 inputs for that range, that doesn't exist there either. So this is basically the steps to find an inverse. And I remember teaching this in class, and my class got it, no bother. They just learned the 4 steps and went with it. So step 1 is we change f of x to y. Step 2 is we change the subject to x. So it's really just changing the subject. Then we switch the x and y around and we change that back to f with a wee minus 1. That's the notation for inverse. And you'll have seen that before whenever you write inverse sign. So you'll say x equals inverse sign of something. That's why we write it, because it's a symbol for inverse. So let's have a look at some of these. So we want to find the inverse function of 4 minus 2x. So let's follow the steps. So we'll replace f of x with y, and that gives us 4 minus 2x. We then change the subject to x, So I am going to bring the 2x over here and make it positive. And I'm going to bring the y over there, so that becomes 4 minus y. Divide everything by 2. I'm going to just, you can either leave it as a fraction, or you could have said that was, for example, because 4 divided by 2 was 2, you could have left it as that. But I think I prefer what I've just done, leaving it as a big fraction. So we'll leave it as that. Then we switch the letters around, so that becomes y, and that becomes x. And then, to write it as an inverse, you write f dash minus 1 of x equals 4 minus x all over 2. So that there is called the inverse function. Let's have a look at the second one. We're going to do the same again. So we're going to change the f of x to a y. We're going to now change the subject to x. We need to undo the divide by 3 and make that a times 3. I'm going to take that 5 over, so that will be 3y plus 5 equals x. Then we switch the x and the y, so that's 3x plus 5 equals y. And then that y now becomes your inverse notation. So the inverse function is 3x plus 5. So instead, we now have a times by 3 instead of a divide by 3, and we now have an add 5 instead of a take away 5. Okay. Question 5. Find the inverse of this function and state a suitable domain. So we're just going to do the same again. So remember, step 1 was write that as y equals x squared plus 3. Then we change the subject. So you've got y take away 3 equals x squared. Take the square root, and that gives you x. Then we change the letters, and then you rewrote the y as f dashed minus 1 of x. So you've got that. Now, suitable domain, that bit underneath the square root has to be greater than or equal to 0. So you've got x minus 3 is greater than or equal to 0, so x is greater than or equal to 3. That is a suitable domain there. Okay. And that's me. Thanks for watching. Okay, and just like my last recap video, I wanted to put in a wee example. So this one was taken from the 2019 paper, and its marks were worth, if I just remember, let's have a wee look. It was worth 2 and 1 mark. Okay, so let's have a look at it. So question part A, determine an expression for f of g of x. So that's okay. So that's just putting in 5 minus x wherever you see x in f. So that becomes 1 over the square root of 5 minus x. So that is part A done. Okay, so just wherever you saw x in f, you put in 5 minus x. Then it says state a range of value for when it is undefined. So it's undefined when the bit underneath is negative. So it's undefined when the bit underneath is less than 0. That's how I always think of it. From there, we want to rearrange this. So you get minus x is less than minus 5. You're going to divide by minus 1, which means you're going to flip the signs. So it's undefined when x is any number bigger than 5. Okay, this question here I pulled from 2016, worth 3 and 1 marks. So this was an inverse function. It's actually quite a nice straightforward one. So we've got f of x. I'm going to change that to y equals 3x plus 5. Then we change the subject. So you've got y take away 5 is 3x. So y take away 5 all over 3 is x. Then at that point, remember, we changed the letters around. So we had y equals, I'm just kind of switching left for right here as well, x take away 5 all over 3. So the inverse function is x minus 5 all over 3. That's part A done. Okay, so for part B, first thing is that if it ever says write down in maths, that means there's absolutely no working. And a lot of times if you do working, you won't get marks here. And in this case, if you did working, they were going to take marks off you here. So they've got that g of 2 equals 7. They want the inverse. So they want the inverse function of 7. Now remember what I did when I talked about my wee functions way back, like it has to go there and it has to come back. So it's just a complete reverse. So if we're plugging in 7 to the inverse, it should take you back to what you started with. And what we started with was plugging in a 2. So the answer is 2. Okay? You could have done it algebraically, but it would take marks off you for it. So thanks for watching. Hope this has helped. Bye-bye.